Fault finding today, and it's one of those intermediate one. This is the magic one. Sometimes is, sometimes isn't. Just been here a few minutes, open up that socket, and we are in a communal area, so we've got few sockets on each landing. This is better than the gym today, so I won't have to go to the gym. So let me show you. This is a communal fuse board. On that one, it's the first circuit on that fuse board. Let me show you what this is. This is that first one, and the plan to actually do this is I will have to ideally find out the last point on this circuit, and then just back to basic resistance. From each point, as I would expect, I can just guess the length of the cable, check with the measurements if it matches what I'm expecting to be. If it doesn't, it possibly go to another socket or there's a bad junction box. So it's just checking everything, and that's what you have to do on the intermediate fault finding. Let's crack on. Okay, I'll position you nicely in here. They say it's on. You shouldn't open the fuse board without safe isolation. Well, I don't have to do it safe isolation. I know what I'm doing. I'm an experienced person. I don't want to take off the supply to the light for other people who's using the stairs, because that would just create a more risk. Someone coming down and falling down the stairs. Let's have a look. So this is what we are dealing with. It appears to be a ring, 32 amps, two cables coming, two cables here. Nothing out of ordinary just yet. Just checking sometimes. Not sure if you see, but the insulation is going all the way down. So I just want to double check on this. I'll be out of breath most of the day today. 4 flights of stairs. Lovely. So let's just double check. So firstly, let's see if it's actually end to end. Right, first point of contact. Just gonna find out if this is a ring circuit. As a matter of fact, 2, 2, 2. I really like these new clips, new improved crocodile clips. These are all right, but these tend to slip from the cable. That one, on the other hand, well, if you put it on the finger, for flipping hell. Ouch. Currently, my meter remembers 0.13 of an ohm as a resistance of the cable. What we're gonna do, by pressing test, we're taking that off by grabbing 2, making sure it's properly connected. 1.4, pressing. So that's our reference value, 0.12. Firstly, let's check live, and so 0.13. That's quite short of a circuit. Neutral, because it's the same size of a cable cross-sectional areas. That's 2.5. That's 2.5 as well. So it should be 0.13 as well. 0.16. So slightly higher. Why is there a difference? In the socket, one of these cables could be coming with the insulation screw. It's almost like this. It's still holding, but it's grabbing the insulation, and it's not good contact, and that's why it's higher. That's one of the potentials. Let's just calculate what this should be. 0.13 times 1.67 by the factor how much the cable, that's 2.5, that's 1.5, the size of the cable. That's how much higher the insulation will be. So that's the factor of 1.67, and we should have 0.21. 0.32. Well, higher. And again, the problem with earth is when you push the earth into a socket, sometimes you're pushing the sleeve and then you're actually clipping it, screw on the sleeve, not on the earth. Anyway, we know it's a continuous ring. Let's just see where the cables are going.
A few moments later.
Ladies and gentlemen, we've got some cables being extended with these little wagos, and that's why the resistance of the cables could be a bit dodgy. Could be as simply as just that. Let's inspect it closer. We might change those wagos to different ones. Pulling these cables, I'm just double checking how well they are actually connected. So first point, when you see blue-brown cables and then the different cables are in the sockets, what we'll have to do is just go over and test the resistance. I'd like to find out, just test each leg at the time, just to see what the situation is. The client is saying that they are losing sometimes as an intermediate fault. So we're not looking for the earth fault, we're looking for a continuity between live conductors. That's exactly what we are going to go and look for right now. 0.3. I'm thinking like it could be just the socket. That happened before. Well, maybe we should test it from the socket. Look at that. I think we found it. I've just plugged in earth and life. It hasn't got anything. It tried to test it, but there is nothing. Nothing at all. Still nothing. On the other side, if I put this on a cable, back of plate, beautiful short resistance. That's it. Ladies and gentlemen, I think we found it. As simple as a socket needs to be changed. Well, it's working, but it's not working, so we're going to go and replace it. So we're just doing a live testing now. We would like to get low ZS. R1, R2 value was very low. We would expect ZS test earth loop impedance to be quite low as well. 0.43. Happy days. Functional testing. Okay. We're going to go upstairs and do some more functional testing and some more hovering. We would expect exactly the same value. A very, very close one. Okay. At that point, what I need to do is I'll need to open up and check the connections at the back for the earth, because that's hugely away from the previous one. The socket feels different. I'm not sure how to explain. I'm not convinced about the socket again. We're going to attach the cables and just see if this is that socket. 1.32. That's very, very interesting stuff. May not be here, maybe a different problem. 1.45. I'll put the earth. Because what I'm doing is I'm not trusting the actual socket, so that's why I'm doing this. 1.13. Okay, no, at that point I know it's not here. Maybe one of those cables was bent more than 3 times, more than 8 times. That one gave us a nice reading because it's close to a fuse board. One of these cables is slightly too far out. Let's just correct this. All right, and the earth is good. Retest. 148. Now let's revisit the fuse board. That's what I was testing, just to make sure that both cables are all in properly. They don't appear to be like put in. It must have been crossed. That's why we test. We test, we verify, we test again. 0.40. That's quite high for TNCS. Should be 0.35. TNS is 0.8. Let's see what happens to those tests now, because all we've changed is just the way how the cables are extended. 0.93. Still quite high, but that's much better than what we've had before. 93, quite higher than what I would want. Let's go check upstairs. It's not reading the voltage. Hello? Houston, someone playing with me. Excuse me, what is happening here? Do you see them little baskets here? That one is fully closed, so the bus bar should not come out. Oh my god, someone made a mistake and they haven't checked this. I've been talking about that thing for however long. Oh my god, that was the issue. Beautiful. 18. And I'm sure we got 18 at the top. 21. That's acceptable. Well, so I'm just gonna give the client what happens here. From just checking the sockets, and the downstairs socket was faulty. That's what it was. So that's why the socket wasn't working. But that's not only at one thing.
There was more than one.
Yes, something really good that I managed to get on camera for everyone to see